welcome to this pre-user check video for the light transportable ventilator, the LTV. We're going to be using the checklist that I mentioned in the last video, so you will see me referring to this throughout. First part is we're going to go through the physical checks and then we'll move on to the functional checks. So starting with the physical checks for the LTV, there are a few items that we need to make sure that we have. The first is our test lung. We should also have a screen protector. This basically slides in and protects from the buttons being pushed by accident. We should have an oxygen hose. We should have a dummy circuit for testing. Obviously the LTV itself. We need an oxygen cylinder, which is down just off screen for you. And we may or may not have a bag for transport. So if you're going to be transporting the LTV, so with a patient either by land or air, then you will require a bag to keep it all nice and neat and tidy. So if you do have a bag, then part of the physical checks are to confirm that the bag looks like it's intact. Your anaesthetist or intensivist will thank you for having a good carry handle for this. Also, we'll have some D-rings on the back and some carabiners, and these are really useful for if you have to connect the LTV to a stretcher harness or to anything else that you might be transporting in. So if you have a bag, we would include this. We would include the bag as part of our physical checks. So once you're happy that you've got everything, then we'll move on to the machine itself. So the LTV itself, the first thing we're going to do is we're going to go through some dirt, dust and damage checks, and we're going to give it a really good once over to make sure it's serviceable for use. On the front we should have an MDSS sticker which is in date. If not, it's going to need to return to servicing, and give all of your buttons on the front a good once over to make sure they haven't been damaged in any way, and then confirm that your liquid crystal display screen again hasn't become damaged and it all looks good, intact and ready to go. You've got two rubber feet or boots as we call them on the top and the bottom. Just make sure that they haven't been removed or broken in any way, because this is going to give you some protection for if the LTV is sort of bumped from one end or the other. So they're quite good bits of kit to make sure they're intact. On the right hand side of the LTV we've got our charging point, so make sure that you have a transformer to charge this and also to plug it into the mains if it's in use. We've got two filters here, so we have our fan filter and our air inlet filter. These two filters, as you've learned from the orientation video, are what need to be removed and cleaned in sort of warm soapy water every 30 days or 750 hours of continuous use if they're attached to a patient, obviously. Just obviously remove the ventilator from the patient, take the filters out, wash them, allow them to dry naturally once you've rinsed out all the soap, and then just reapply them. Underneath this metal cap is where our oxygen hosing is going to connect. So we just need to bear in mind that safe use of oxygen principles of making sure there's no dirt or grease or dust or anything stuck in there, and make sure that that cap remains on at all times if there isn't an oxygen hose connected. Got a couple of ports in here which we don't use, but they can be connected to communication systems, but we don't have that with the MOD variants. On the opposite side we have a opening which is where our speaker is going to be. This is where you're going to hear alarms out of, so make sure again nothing stuck in there that will prevent you from hearing the alarm. We have our three transducer sections, so just give them a once over. And then as mentioned in the orientation video, we have our 22mm connection for the ventilator, for the actual hosing. You'll notice that this plastic part here is stuck in most machines that you come across. It is actually a single patient use and it is found in a new LTV circuit, but most of them have got them stuck in there. What we would advise is the new circuit that you get, take the 22mm connector out from your bag and place it in a rucksack just in case, because if this falls out randomly, it's really useful to have a replacement, because otherwise you can't connect your ventilator to the patient. Once we're happy, given that a once over, we're going to move on to our oxygen hosing. The hosing itself should have a like a rubber band on it, which has got a date. This one's dated 2017. The hoses have a 4-year life, so just confirm that the hose is still in date and good to go. You should have a valve, so this is a hand tight valve. We don't want you to undo it to do it back up again. Okay, there's no need, just check that it isn't loose at all and just hand tight. This is the one that's going to make sure it regulates the pressure sufficiently for the LTV from the cylinders. Check your Schrader valve, make sure that there isn't, again, any dirt or dust or particularly grease, anything that's going to cause a fire hazard. And then, as per the orientation video, have a good look at that rubber washer, that Bodox seal on the inside of the oxygen hosing itself. Make sure there isn't any teeth cut out of it or anything that's going to make you have a big leak in oxygen. It's good practice to give your ventilator circuit a quick once over. Now this is obviously a training circuit, and you will use training circuits for the routine 373s of the piece of equipment. But if you get out a new circuit, there's a few things that we would recommend you check. First is the integrity of your sort of right angle ports up here. It's quite brittle plastic, they can break very easily, so when you get it out of the packet, just confirm that nothing is broken. On the PEEP valve itself, have a good look inside, make sure that that spring is still intact, and just have a go at adjusting that PEEP setting, just to make sure that your valve is going to work. And finally, working your way down to your transducer ports, just make sure that you've got 3 of them. You should have a yellow, a white and a plain one, and make sure that they're all intact and good to go. Completed the physical checks of the ventilator, we can move into the functional checks. To perform these functional checks, you should make sure that the oxygen hosing is connected and tightened, and that this hosing is connected to an oxygen cylinder which has some oxygen in it, because we're going to need to check that in a minute. You need to make sure that the patient hosing is all connected and the transducers are correctly connected. You'll have an opportunity to practice making these connections whilst on the course. You can perform this check plugged into the mains, so don't worry, you don't need to work off batteries at this point. So the first thing we're going to do is we're going to switch it on in its test mode, and to do that I'm going to press and hold the select button whilst switching it on, and I'm going to keep my finger on that select button until it confirms that the patient is removed, and you'll see that by the text on the display. So press and hold select and turn it on. Keeping my finger on that select button, it goes through a couple of checks and then it comes up with remove patient. You can now remove your finger from select and just press silence to take you into that vent check menu. So this first menu is the ventilator check menu, and to enter that menu we're just going to press select. The first option here is an alarm. Now what you've got to imagine that these are menus within menus, and it can get quite confusing, but this is why it's really important that you follow that checklist all the way through. So here I'm going to press select again, and what we're going to do is we're going to hear the audible alarm. So press it and we can hear the alarm. And to shut it up, basically press select again and it takes you to the next part of the menu. This next part is a display, and it's confirming that all of the lights function on our display. So if I press select, all of the lights should light up. So just go through and make sure that all of the lights on the LCD all function correctly and that you have lights visible. If anything's missing, then you should return to MDSS to be fixed. The only light that won't be visible is this vent in-op light, and that becomes clear because that's an important light to indicate that the ventilator is inoperable. So at this point, that is the only light that will not come on in the display. Press select again and you come out into a menu function called control. This function is going to test all of the buttons. So when I press select, it will tell me that I have pressed select. And all it wants you to do is go through each of the buttons and confirm that the button that you've pushed is reflected in the menu. And so you just push all the buttons to confirm that it is what it says it is. You can even press the on standby button. And the second time you press select, it will take you back out into the original menu. Here we're going to perform the leak test, and to perform that we're going to need to occlude the Y piece of the ventilator. We can just do that with a thumb, so just place your thumb over the Y piece and press select. What we're looking for here is to confirm that it achieves a pressure of greater than 45 centimetres of water, and that we don't have a leak of any more than a litre. So we can see our pressure's achieved 59 here, so that's fine. And in a second it will tell us our leak. So we have a leak of less than 1 litre, and we achieved more than 45 centimetres of water, so it's passed its leak test. Pressing select again takes us into the exit, and at this point we need to remember to switch off the LTV altogether, because what that's going to do is confirm that our vent in-op light works and that the alarm works as well. So this can be a reminder to switch off the whole of the LTV. So press and hold on. You can hear an alarm and you can see that vent in-op light has become visible. And we'll silence it, and we should allow that to alarm for up to 15 seconds just to confirm that that functions correctly. To get back into the menus, we're going to have to press and hold select again and switch the LTV on. Again, waiting to remove your finger from select until it gets to remove patient, and just silence that. So we've completed our vent check. And next we're going to move on to our alarm operation. So if we turn the dial clockwise, it does take us to an exit menu. Don't worry, just turn it clockwise once more and you get through to the alarm operations. In here, if we press select, the first option is to confirm what the alarm volume is. If you press select, it should be 85 decibels, which it is, so that's correctly set. Press select again to go back up to the previous menu. This is where you're going to have to turn the dial, because these are menus within menus, so you can get a little bit lost here. But the next option after turning the dial to the right is apnea interval. So if we press select, it gives us a 20-second interval. So the LTV will allow the patient to go apneic for up to 20 seconds before it goes into an apnea backup. You can adjust that, you can go up and down on that, but it's set at 20 as standard. Press select to go into the upper menu and then turn the dial to the right to go to the next option. Here we have a high pressure delay, and this is an alarm that would become audible if there was a high pressure in the vent circuit. And we effectively don't want any delay on that. If there's any high pressure, so pressure above the high pressure limit that you've set on the alarms, we don't want any delay before it alarms at you. So just have that set at no delay as standard. Pressing select takes you back up to the top menu, turn the dial to the right, and we're into our low peak pressure alarms. Now this, if we select it, should be set on all breaths. The way I remember that low pressure alarm is it's a really useful alarm for a disconnect, because if you have a low pressure, then it's likely that you've just disconnected the circuit, or it's become disconnected at the ventilator or at the patient end. So it's helpful to have that on at all breaths so that it's always monitoring low pressure. Press select again to go to the upper menu, turn the dial to the right, and we get to our high frequency menu. Here you can set this specific to the patient, and you can set whatever frequency you think is suitable. So what this is going to do is if you set it at 30 breaths per minute, for example, but the patient breathes at 35 breaths per minute, it will alarm at you to tell you that you have a high frequency. So you can go into that menu and adjust it, but for this we're just going to move on. Next option here is the high PEEP alarm. We would recommend that you have this switched to off. So if we press select, currently it's set off. And the reason for that is that it prompts you to set a high PEEP alarm once you've started ventilating the patient. So start off with it off, and then the LTV will remind you that that is currently set off. Pressing select, back up the menu, and then turning the dial to the right. Patient assist, you don't have to worry about. It's related to the some of the ports on the side that we don't use, so you can ignore that one. And then we're into exit. So we've been through that alarm op menu, and we've got one more menu to look through. So if we exit that menu and turn the dial to the right, we now have our ventilator operations menu. Select the menu to go in, and the first option here is our rise time. And the way I remember this is it's a bit like, if you're used to using Draeger's, it's a bit like a ramp. It's how gentle you want to deliver the breath. You can either deliver the breath very harshly in and out, or you can give them a much more gentle flow of inspiration and expiration. This is set as standard at profile 4, just because that's the most effective profile that certainly on CCAST we've found, but you can adjust it if you want either a more harsh or a more gentle delivery of the breath. Next, we've got our flow termination. So we now have two different ways of terminating spontaneous breaths. So we have our flow termination, and the next menu is our time termination. So effectively, this is a way of controlling the spontaneous breaths. You can control the mandatory breaths by using the inspired time. Here as here, but for the supported breaths, obviously we might want a bit of control over that. We don't want our patient inspiring indefinitely. So we can do that by using the flow and the time termination. And as standard, we have our flow termination set at 25% of peak. So if the inspiratory pressure hits 25% of its peak flow, then it will cycle into expiration. And we also have our time termination, which will terminate a breath into expiration at 1.5 seconds. So you can adjust those two if you need to, but we tend to keep them as standard those. And it's whichever one of those numbers hits, it hits first, will terminate a spontaneous breath. Next is our pressure control flow termination, and this is just an alternative way of controlling our I to E effectively. On the LTV, we choose to control this using the inspired time, so we will set a time based on the respiratory rate that we require, but you can terminate those breaths into expiration using this termination option here. As standard, we would have it switched off in the menu because it doesn't seem to have much utility. But obviously, if one of the anaesthetists or intensivists want to select that as a function, then you can have it on, and it will try and mirror the flow of the spontaneous breaths. So we prefer to have it off and just rely on the inspiratory time and the respiratory rate for cycling, but there is an option in there for pressure control flow as well. Leak compensation, well, it seems obvious that you'd want some leak compensation on. We know that we have a very small leak with that circuit, but this will compensate for up to 6 litres. This NPPV, so or non-invasive, whatever terminology you want to use, we would have this obviously switched off, but the LTV is capable of doing NIV if you have the correct masks. But having it switched off is just a safety feature to prevent you accidentally trying to deliver NIV to an invasive circuit. Oxygen flush should be set at 3 minutes, and this is how long we can deliver 100% oxygen should we need to. So 3 minutes seems a pretty good default to have. Control unlock is set as a default as easy. Don't worry too much about that. That's just a way of unlocking or locking the buttons, and the easier you have it, the better, because it's not the most intuitive option there, but keep it at easy. Language is obviously going to be English. You don't need to go in this menu because you're reading the menus in English, so we know it's in English. The version should relate to, so certainly the MDSS guys Tactical Medical Wing will put the software versions on, so you can confirm that those two versions are suitable. If you don't have that sticker, don't worry too much. It's just a confirmation of the current software settings. This usage function is for MDSS, don't worry about that. COM settings we don't use, and then we get into set date and time. So it's obviously set it to the date that it is, and set the time to either Zulu or local time, whatever timings you're working on. Date format, don't worry too much. You can obviously switch it to an American or a British version. Now this menu, this one hidden right at the end of the menu, is our peak inspiratory pressure LED. You would have seen from the orientation video that as the barometric pressure increases, so you see this airway pressure barometer going up and down with each breath, this PIP LED function leaves a LED at the peak inspiratory pressure. So it's a really good visual indication of what the patient's peak inspiratory pressure is. So we would have this set as a default as on. Just scroll through the rest of these, don't select defaults. O2 cylinder doesn't work anymore because it's based on the old steel cylinders, so it doesn't work for the double-skinned white cylinders that we use now. And then scroll through to the exit. Once you've been through all those functional checks and you've been through those three menus, we're going to move into our real-time transducer data. This is going to require the test lung because the LTV is going to be ventilating, so just get that connected up to the Y connector. And if you have an external battery supply, then you need to get those out ready. So these batteries should be readily available because, as you know from the orientation, the battery life on this is only about an hour. So this is going to give you an extra 3 hours on top. And we need to confirm that the voltage is suitable on these batteries, and we'll do that in this next menu. So moving on to real-time transducer data, you'll see here that the ventilator is obviously ventilating, and how I got out of that last menu was by pressing this control lock button. If you press it, it kind of acts like a back button. So press it once and it took me into the upper menu, pressed it again and it took me out of menus and into a ventilation mode. Alternatively, you can switch the whole ventilator off and on again, but that is just the quickest way to get into a ventilation mode. From here, the checklist talks about doing this real-time transducer data in a set mode. So you'll see here I have a respiratory rate of 12 and the pressure control and support at 15, an inspired time at 1.6 and a sensitivity set at 3, and I am in a pressure SIMV mode. The reason for having it standardized is just that every time a transducer check is complete, then it's done with exactly the same settings. So to get into that transducer menu, I'm going to press and hold the select button, which takes me into our menus. So we've already been through some of these menus, but we'll just scroll through to the right until we get to where we want to be. And this is the menu you're looking for, this RT XDCR data. So this is the real-time transducer data. And we'll press select, and it takes us into some numbers that it's monitoring as the LTV ventilates. You can also, we're going to do this as part of the pre-user check, but you can also do this during the mission. So say it's alarming at you have low oxygen or that low battery voltage, and you can go into the real-time transducer data to see this as well. So a lot of these numbers we're not going to worry about, so we're just going to scroll through until we get to the first one that we worry about, which is our oxygen PSI. So this should be monitoring a PSI between 40 and 80. But as we mentioned before, the actual valve set on the oxygen tubing is set at 55 PSI. So you would assume that your oxygen PSI should be at about 55. Now the other thing here is I'm not actually delivering any oxygen through the LTV, so we've already got a low PSI with no oxygen delivery. So I'll show you what happens with a poorly functioning oxygen hose. So if I deliver 100%, you can see how that PSI drops off. So this oxygen hosing isn't functioning the best it can be. So to troubleshoot, make sure you tighten up any connections. So actually a bit of tightening up there has improved the PSI already. And just have a good look at your oxygen cylinder to make sure that you've got some oxygen connected. So we'll pop that back down. So in this instance, we're using training kit, so the hosing isn't always that effective, and we often use only partly full oxygen cylinders, hence why the PSIs are quite low. But what you're looking for here is a PSI of around 55, but greater than 40 is sufficient. Next, we're going to look at our battery voltage. Now, obviously this is connected to the mains at the moment, so when I disconnect, it's going to alarm me that the battery is disconnected. Just silence that alarm and reset it. And this is calculating the voltage of the internal battery, and we need it to be greater than 12 volts, which it is. So that's fine, that's suitable. This is also where we would check any external batteries. So to confirm our external voltage, if we scroll to the right, we now have an option for external voltage. And to do that, just connect up your battery in the same way as you'd connect up the main supply. And again, look for a voltage of greater than 12, which is sufficient and means that your battery should last for the expected 3 hours. Once you're happy that all of your real-time transducer data is functioning correctly, you can use this control unlock function to come back out into ventilation mode, and you are good to switch off the LTV and return it to the shelf back on charge. That concludes the lesson on the 373 pre-user checks for the light transportable ventilator. You'll get plenty of time to get hands on this piece of kit whilst you're up on the DICE course, and there'll be loads of subject matter experts around that can help you if you have any questions. Thank you for watching.